Alright guys, it's KK4PY in here again. Today we're going to be taking a look at the Cushman CE-15 spectrum monitor. This is a handy tool for doing radio repair, or building radios, anything radio related really. Basically what it is it's a receiver. It's a triple conversion super heterodyne receiver. And it's got the video output in an oscilloscope pattern. It shows a visual representation of your signal power, time domain over frequency, etc., etc. So basically what you're looking at on the screen is the radio signal, kind of like you would if you've seen any of my SDR videos. You'll see basically the same thing. It's a spectrum analyzer display. So right now, as you notice, we've got this one peak here. The receive on this is from 5 megahertz to 1 gigahertz, 1,000 megahertz. Is the range that it covers. And as you can see right now, I just got it plugged into this whip antenna. It's plugged into the BNC port on the front. As we go through the video and the camera moves around, it may have a problem with the sync, the refresh rate of the screen there. Hopefully it comes out good. So at any rate, right now you can see we got it tuned to 162. And that spike that you're looking at is the National Weather Service broadcast out of Melbourne, Florida on 162.475 FM. So if you look down here at the scan width, we got it set at 1 megahertz. So you're looking at, I've got to go back and look, but it's either 1 megahertz is entirety or 1 megahertz on either side of the frequency 0 line, which is the center frequency. I don't think you can see it. I'm going to zoom in here real quick. Let me see if I can change the resolution a little bit. There we go. I don't know how well you can see it, but if you look on either side of the signal, you'll see other little peaks, and that's just the other weather broadcast stations around there. So what you'd use this instrument for is looking at the output of a transmitter or a transceiver to make sure you don't have any spurs around your signal, spurious emissions or big spikes or anything like that. And sorry about that. Phone rings at the most inopportune moments. And also we're looking for interference. So as we tune this, I'm trying not to bump the camera as much there. As we tune this back and forth, you can see the center frequency, and you can look at what's up and down the band. We get into the ham bands here. I'm really not picking up anything tremendous, but we go up here a little bit. So this is all basically just noise. There's a difference in signal. There you saw something up there in 170. So that's another signal coming through. So one of the uses could be really as a band scope. You're looking at what's on the band. Granted, this is really targeted for VHF, UHF. You would probably find this instrument mainly in a 2A radio shop. But anyway, let's go down to about 30 dB there so we get a nice clean trace. And this will actually demodulate the FM. We switch over here to monitor FM. And a little bit of tune in here. See if we can pick up. This is our fine tune down here. I know I had it before. Let's see a little bit more. Down. It's real touchy. Which is what the fine-tuning control is for. It's almost hard to keep it on 162 here. Let me move the camera over so I can get a little bit closer to this thing. There we go. So, now what we've got is the National Weather Service, which is a narrow-banded FM station, and you can see this is the modulation line up here. And as she talks, you can see the dips, but when there's no speech, you're just seeing the solid carrier. Obviously with AM you'd see a totally different display. So basically a non-modulating FM modulation, if that's what you really want to call it. It's just a solid line. And with our reference signal here, negative 40 dB, we're looking at a signal that's negative 30 dB strong off of this antenna. So this thing was built in 1977, so I'm not really sure of how accurate it is right now, but it seems to be on frequency and working pretty good. So we'll turn that down, and we'll go back over here to 1 megahertz scan width. And if I tune down through the band, we'll get down here into some familiar territory. Alright, now you see these signals starting to come across. And look where it starts. Right about 106. 106 megahertz is your FM broadcast band. So as we tune down through here, there's a big station here in Orlando at 106.7. There's another big station here at 98. It looks like it's gone off frequency on me a little bit again, but either way. And tune down here, and about 88, 89 signals go away. So what you're looking at there is the entire FM broadcast band. You can just sweep through it just like that. If we take our resolution out, I know it's really hard to see. I'm going to zoom in here real quick. And I don't know if you'll actually be able to pick it up because of the refresh of the camera. But right in the middle here, you're looking at the entire FM broadcast band. And then a bunch of other garbage. And as we tune up, you'll see this is probably some aircraft traffic. Here's some... That right there is the National Weather Service broadcast. So if I zoom back in at 162, zoom my camera back out, there we go. So using it as a band scope works good. As a receiver it works okay. It'll demodulate AM and FM. Also handy for looking at noise. You got noise in your area. Like here's a spike at around 65 megahertz. No idea what that is. But you can see different signals as you zoom down through, and these are could be birdies internally, but here's 28 megahertz. 28 megahertz would probably be AM. See if we can tune something around in there. Well, whatever it is, that's what it looks like. On AM or FM, the signal looks pretty much the same. That's probably some sort of noise. Down, way down. Look at this. That's the end of where this thing really tunes to. It's not even supposed to go to 3 megahertz, so that is just some massive noise spike. Look, all the way down to 0 dB. It's just massive. So that's probably in the internal oscillator, what it's picking up there. Its calibration oscillator is way up at 189 megahertz. And the way the mixers work in this thing is designed to keep any of the spurious emissions and birdies and stuff like that way out of its receive range. It mixes, you know, like way up into the 2 and 3 gigahertz band, and then, you know, it's got 3 mixers in there, so it's, like I said, it's triple conversion. I've got the service manual that shows what they are, but anyway, it'll help you to find noise and target, you know, if you're having a problem, let's say you're having a problem on 10 meters and you hooked it up to an antenna, preferably a 10-meter antenna, and you could look at what, you know, where your noise is, and it would possibly help you figure it out. So but what I'm going to use it for is something a little bit different. So we're going to go back up here. There's your FM band again. We're going to go back up here to 146-ish. I'm going to do negative 20 dB. And got the trusty Radio Shack HTX 420 here. Turn that on. 146.8. Yeah, let's come down a little bit. Come down into simplex area. Okay. So I'm on low power at 146.585. And key this up. Yeah, there it is. There's our signal. You can see the transmit light come on. Beep. And there's the signal on the scope. So what I'm going to do is I'm going to zoom in on that signal. This is all kind of hard to do one-handed. Alright, so if I transmit again, you can see that the signal looks nice and clean. There's no KK4 PYN testing since we are transmitting out over the air, even though we're in low power, which is like a 1 watt or less than 1 watt on this radio. You can see the signal's nice and clean. Okay, so what does that tell us? Well, it tells us this is a commercially made transmitter with all the proper filtering. And if we were doing something homebrew, sorry, I'm just trying to get I'm actually holding this camera with my knees on a little monopole here, because I got to do a 3-handed operation. Okay, so we're going to transmit again, and now what we're going to do is we're going to look up and down the band. There's the spur up there. Well, if that's gone, that was probably something else. But you can see there's really nothing on either side of it, and if we zoom in, we can zoom way in on this signal here on 100K, and we can really look at what the output of the transmitter looks like. So really handy for if we go up here to a plus attenuation. You can see the signal is basically nice and clean. So at 0 dBm, there you go. You got a beautiful signal, nice and clean. So that tells us that the old Radio Shack HTX 420 is working good. I've looked at that on some other radios and it looks just as good. So those are commercial radios. So what does that mean for me? Well, over here, that's the BitX20. since this will go down to 5 megahertz, we'll be able to look at the output of that. I can look at the output of the Pixie, because the Pixie is at 7 megahertz. And I could look at the output of the ICOM here on some of the higher bands. Really not designed for sideband, but I'm curious to see what it'll look like on a CW signal or a sideband signal. I haven't tried it yet. Now the maximum input on this unit is plus 20 dBm. Right there. That's 0.1 of a watt, 1/10 of a watt. So you wouldn't want to plug this into the back of your transceiver. You can put a high Z microphone or oscilloscope probe in there and probe your circuit and your transmitter, you know, and the output of your driver or something like that, no problem. It originally was designed to be used like this with an antenna. There's actually a 1/4 amp RF fuse inside that BNC connector to prevent it from overpower, which is good. So let's look at that. Let's do another real quick thing here. I showed you there's no problem picking up the weather channel, which is a narrow banded FM transmission. But the broadcast band is wideband stereo. See if we can find a strong signal in here. Alright. It really takes to tune in. It takes a lot to tune in an FM station, but it can be done. It's not very clean, obviously, because it's so wide. But at any rate, before we get to 20 minutes here and all you guys fall asleep, let's look at the Cushman CE-15 spectrometer. They're pretty expensive. Like I said, this is from the 70s, but I've seen them going for still for a couple $100. But if you're just going to be looking at, you know, VHF, UHF, like when I get the ham shield or one of these little Arduino controlled 2-meter or tri-bander rigs, this will be real handy if I decide to build an amp for it or a PA, to make sure that the output of that transceiver is clean. Like I said, I don't know how well it's going to do on sideband or CW. That's something I'll have to look at, but for VHF, UHF work, it's fantastic. It's also good for finding noise. You know, we saw those big spikes. And looking at spurious emissions is what it's really designed for. So, looking at the waveform output of your transmitter, because we really don't want to transmit a bunch of garbage over the air. As homebrewers are responsible for making sure that we're not just getting a bunch of gobbledygook, because that's not cool. So, you'll see this in future videos in more of a, you know, a test environment, looking at the output of some other stuff. And as you saw in my last video, we've got lots of projects on the bench here, things to do. I'll have a video coming up soon with the this VFO here. This VFO is out of a Yaesu FT707, and it's kind of nice because it's easy to get it working. It's got just a couple outputs from the back there. It's got RF output. It outputs 5 to 5.5 megahertz, which apparently is pretty popular in some homebrew transceivers. So it's got nice mechanical movement. It's very smooth. It's a very nice VFO. A quick tuning ring around the outside here. It's just beautiful. Runs on 8 volts. Outputs, you know, a volt peak to peak, whatever. And I had it hooked up to the homebrew frequency counter here, and it's just rock solid. It's good stuff. So that's another video for another day. And you know, I've just been working on getting all this stuff up and running. I played with that little receiver the other night, couldn't get anything out of it, but at any rate, we got all the projects coming up here. So I did last night take the SB104 and powered it up, some very low amperage. It all powers up. The display is a little bit wanky. These gas discharge displays are notorious for having problems. There's fixes for that. But it powers up and it seems to tune, so wasn't really receiving anything. I just had hooked up to a little whip antenna, but I took all the cards out one by one, checked them over, fixed a couple solder joints, looked for anything burned up, made sure the contacts were clean, went down in here and cleaned up some of the switches with some contact cleaner, and I made sure that all the connections back here were good. So at any rate, it powers up and there's no smoke, which is a good thing. Obviously I haven't tried transmitting yet, but that's the very last step. There's some step-by-step stuff on the internet to go through and check it out, but that's another video, another project. I'd really like to get this radio on the air and get it revived. So at any rate, that's been our look at the new tool here, the Cushman CE-15 spectrum monitor. If you have any comments or questions, make sure you leave them below. We'll do the obligatory finger down below thing. And I'll turn the phone off here because everybody seems to want to call me while I'm doing the video. Sorry about that. And please like and subscribe. As I said, we've got the giveaway from the last video. If you didn't catch that, we're giving away the an STM F32 dev board here. You go back and look at the last Monday Module Madness video and you'll see some info there. So at any rate, this is getting long-winded. Thanks for sticking with me, guys. Stay tuned. There's always more to come. 73.